So, welcome back. A couple of things today. We've got 3 examples that I would like to go over today to get you back thinking of navigation type problems. Then I have a bunch of stuff to hand back to you, including the formatives that you took before spring break. If you haven't taken those formatives yet, make sure that you get those done today, so the potential is there that I can get it back to you tomorrow. Okay? And I also have your quarter grades for you. Hand those out here in a little bit. Okay? All right. So let's start with these 4 problems. So the magnitude of V is 20. The direction angle of V is 170 degrees. The magnitude of W is 55. And the direction angle of W is 317 degrees. I need you to find me the vector 2V minus W, the vector V plus W, the magnitude of V plus W, and the direction angle of V plus W. Okay? Go for it.
I suppose if I told you you needed a calculator, I should probably get out a calculator. So 20 cosine of 170. And then 55 cosine 317.
All right, so 2V, 2A plus H. I'm going to round up 3 decimal places. Oh, tap the brakes. That should have been a minus. I put a plus. That looks better. That looks better. This vector is in quadrant 4, so that means we're going to go 360 minus our reference angle. I get a direction angle here of 301.095 degrees. Questions, comments, concerns, clarifications? Yes, sir.
What's the stuff you're doing with the quadrant that was in the end and subtracting certain?
Well, this that we found was the reference angle.
Oh, I know.
So this vector is in quadrant 4. So the reference angle we found is off the horizontal in quadrant 4. So the trig angle would be 360 minus the reference angle.
Oh, okay, so it's fine. Because
We want the actual angle, yes, not the reference angle.
or a navigational angle. Or
This is not a navigational problem. Okay. Other questions? Alrighty. Three forces with magnitudes 100, 50, and 80 pounds act on an object at angles of 50 degrees, 160 degrees, and negative 20 degrees, respectively. Find the direction and magnitude of the resultant vector. Go. What am I going to do with all three of those vectors? Add them all together. Okay. So when I add them all together, that gives me that. That gives me a magnitude of 113.807, and that is pounds. It's in quadrant number 1, so actual theta is going to be inverse tangent of that. No need to adjust because it's in quadrant 1. Yes? Questions, comments, concerns, clarifications? Trig angle is the regular angle. I'm confused.
Like, so for the, there's like a question where instead of us using 50, we have to use 310 instead, since it's on the opposite side of the arrow. Does that make sense?
Navigation problems have a different starting point and go in a different direction, I think is what you mean. If but it wouldn't be 310. If we had a navigation angle of 50 degrees, that would be a trig angle of 40 degrees. Okay. All right. Have at it. While vacationing in Italy, a man named Quentin whisks you away in a beautiful yacht to the city of Palermo in the city of Sicily. While aboard, you meet the sweet captain named Tomasotto, who, while he doesn't speak English, shows you the gauges that indicate the true bearing and speed of the ship is 27 knots at south 42 degrees west. The wind is from the southeast and blowing at 3.5 knots. And the current is pushing the boat at an angle of north 18 degrees east at a speed of 4.3 knots. What is the actual direction the bow of the ship is pointed, and what is the actual speeds the engines would have to achieve in still water and air to maintain the trueness of it? Go for it. True bearing is G. South 42 degrees west gives me a 42 degree angle in there. That gives me a trig value of, yeah, go ahead. 232.28. Right? 270 minus 42 is 228. So that's going to be 27. Yes? Okay. Then we got the wind. Green for trig angles. Then we've got the wind. Wind is blowing at 3.5 knots. Wind is blowing from the southeast. So if it's blowing from the southeast, that means it is blowing to the northwest, which would be a trig angle then of 135. Then we got the current. Current is going at 4.3 knots. Current is pushing the boat at an angle of north 18 degrees east. So that's my 18 up there, which would give me a trig angle of 72. Right? So the actual plus the wind plus, in this case, the current is going to give us the true speed. We added a variable in there for current and wind. Okay? Which means we need to find A, because we don't have A yet. So A is going to be G minus W minus C. So that's going to be 27 cosine of 228.
Hold on.
27 cosine of 228 minus 3.5 cosine of 135 minus 4.3 cosine of 72. That's going to give me negative 16.920. Then I got to do the signs. 27 sine of 228 minus 3.5 sine of 135 minus 4.3 sine of 72. That's going to be negative 26.629. So the magnitude of A then is the actual speed in still water. So then that would be a square root of negative 16.92 squared plus negative 26.629 squared. And I get it is churning at 31.550 knots. Then find the inverse tangent. And that gets me 57.568 degrees. This is in quadrant 3. So that 56, that reference angle that we found is there. It gave us our directions in the north, south, east, west flavor. So that's how I need to give my directions in that one. So I need to go 90 minus my theta prime. Gets me that. So the direction angle would be south because we're going down. 32.432 degrees west. Questions, comments, concerns, clarifications? I have things to hand back now. You also have a mod that you can be working on your homework packet. If you went on the Canvas during break to do some homework, we intentionally were nice and put on the worked out solutions over spring break. Now we have switched them back to just answers. Okay?